Thank you for tuning into my channel. Don't forget to click on like and subscribe if you like what you see and you want to be notified when I release future videos. This video is a walkthrough implementation of how to connect two Azure virtual networks using global virtual network peering. So our focus in this lab scenario will be on configuring that connectivity between the core services VNet and the manufacturing VNet by adding peerings to allow traffic flow. And for those who may not be aware of it, these peerings are actually a pretty beneficial feature because they allow us to bridge that connectivity between individual virtual networks, which by default, that communication, that network traffic flow is not allowed to traverse from one virtual network into another by default. There must be some other mechanism in place in order to allow these isolated virtual networks to pass network traffic between each other. Let's take a quick glance at the Microsoft documentation for a little more information. To the Microsoft documentation, virtual network peering enables us to seamlessly connect two or more virtual networks in Microsoft Azure. The virtual networks will appear as one for connectivity purposes. The traffic between virtual machines and peered virtual networks uses the Microsoft backbone infrastructure, which is really beneficial because that traffic will remain private rather than being sent out over the public internet. That network traffic between the peered networks will remain on the Microsoft backbone, giving us a lot of added benefits, value-added benefits, such as higher throughput and private connectivity. Now, like traffic between virtual machines in the same network, the traffic will be routed through Microsoft's private network only. Azure supports the following types of peering. We have virtual network peering, which is just connecting two virtual networks that reside within the same Azure region. However, we also have something called global virtual network peering, which is similar except that we are connecting virtual networks that live in different Azure regions. Now, the benefits of virtual network peering, whether that's a local or global peering, include we get a low latency, high bandwidth connection between the resources that are in the different virtual networks that are communicating. The ability for resources in one VNet to communicate with resources in a different VNet. The ability to transfer data between different virtual networks across Azure subscriptions, Azure Active Directory tenants, deployment models, and Azure region. We have the ability to peer virtual networks that are created either through the Azure Resource Manager or those that are created using the classic deployment model. And there's no downtime to resources that are experienced in either one of these virtual networks at the time you are creating the network peering or anytime after you create the network peering. The network traffic between the peered virtual networks remains private. The traffic between the virtual networks is kept on the Microsoft backbone network. So there's no public internet involved here, no gateways or encryption is required in that communication between the virtual networks. So let's take a look at our scenario. The task that will be required in order to successfully implement this peering will be task 1, we're going to create a virtual machine to test the configuration. Now, we already have a virtual machine that was deployed in the core services VNet on the prior lab video lab walkthrough. Please see that video if you were not with us at the time of that virtual machine creation. However, in this walkthrough implementation, we're going to create a new virtual machine that will live in the manufacturing virtual network, and it will be used to test out the communication between this virtual machine in the manufacturing VNet and the virtual machine that lives in the core services VNet. So we're going to connect to the test VM using remote desktop protocol connection, and then we're going to test that connection between those virtual machines. Now, upon our initial test, we're going to find that these virtual machines are not able to communicate with each other because at the present they reside or they live within isolated virtual networks, and this peering connection has not yet been established because by default virtual networks do not allow inter-VNet communication unless we implement some type of mechanism such as a peering to allow that network traffic flow. So in task 4, that's where we're actually going to create that VNet peering between the core services VNet and the manufacturing VNet. And then finally in task 5, we will test that connection between the two virtual machines, and we will successfully achieve communication between these VMs that live in different virtual networks. Well, with that being said, let's get started. And here at the Azure portal, we have the 3 virtual networks that were illustrated in a diagram that were previously deployed during the previous video implementation. Within these virtual networks, we have a set of test virtual machines that were deployed to the core services VNet, test VM1 and test VM2, both residing within the core services VNet, which lives in the East US region. I think I should probably turn them on because I deallocated them after the previous lab, so that way I would not continue to accumulate costs for the virtual machines, but we still accumulate costs for the storage. So that's something important to keep in mind when we deallocate virtual machines. And our first task here is to deploy a virtual machine that will allow us to test the configuration. We are going to create this test VM on the manufacturing VNet, and this will allow us to test whether or not we're able to access resources inside the other Azure virtual network from the manufacturing VNet. So that's going to be VM from the manufacturing VNet to the virtual machine that resides in the core services of VNet. So we'll utilize probably this test VM1. So to begin the deployment of our new virtual machine, we're going to do that using an ARM template that is written in JSON. So I'm going to request a Cloud Shell. Let me raise this screen. We're going to upload the template file and the parameters file. Upload. And we have manufacturing VM deploy. I'm going to open. And that has successfully uploaded. And next we're going to upload the parameters file. Azure deploy parameters. Open. And that has completed successfully. I'm going to paste in my command. Let's see, let's clear this screen. I don't like extra contents on the screen when I'm trying to work. All the extra clutter. I'll go ahead and paste in that command, PowerShell commandlet, and that will kick off the creation of the test virtual machine in the manufacturing VNet. We'll go ahead and pause the video at the moment, and I will return once that virtual machine deployment process has completed. And based on the output from our PowerShell Cloud Shell pane, it appears that the deployment of that virtual machine has successfully completed. We'll go ahead and close this. I'll go ahead and close the Cloud Shell, and we can test and make sure that our virtual machine appears. Looks like we now have our manufacturing VM, and it lives within the manufacturing virtual network, which is located in the West Europe region. So that looks okay. We have a public IP address that has been associated with it, just as the others. Looks like we ended up with a different VM size, but that's fine. This was based on within the contents of what was available within the Azure template on template file. So in our next task, we're going to connect to the virtual machine using a remote desktop connection. So from the Azure portal page in our virtual machines pane, we're going to click on the manufacturing VM, and we're going to download an RDP file by clicking on connect. And this is going to use port number 3389 for RDP. We're going to click on download RDP file. Let's click on download. And once that has completed downloading, we're going to go ahead and open it. We click on connect, and we're going to type in the user credentials that will allow us access to connect to this virtual machine. believe it was test user. And click on OK. Looks like we've reached the front door here of the manufacturing VM. Let's complete the establishment of that connection. Next, we're going to also connect to the test VM1. So let's finish letting our manufacturing VM load. So Windows Server VM. You can see the server manager is loading. And we should get a pop-up box to accept connection. Oh, I guess it did not pop up. Okay, so next we are going to connect to our test VM1 using a remote desktop connection. Same process, we'll click on the VM. We will go to the Overview tab. We will go to Connect. And then we will download an RDP file. We will initiate that connection, connect, type in the credentials for that VM for this user. This was established in the template file as well, the user credentials. Press OK. And we will allow our connection to establish here to the test user login to this test VM virtual machine here. If we see any privacy settings on our device or for networks, we'll just click on accept. Click on yes. So our next step here is to test the connection between the two virtual machines. And to do that, we are going to, from the manufacturing VM, we're going to utilize what is known as the testnet connection command from the PowerShell prompt. So from manufacturing VM, we'll click on the start button, and then we will initiate the run of the Windows PowerShell application. Let me get my window sized here. And from the command line prompt, we're going to type testnet connection. I need the IP address of our test VM1. So here we have our test VM1 networking. And I have a private NIC of 10.20.20.4. That's also available on the overview pane. I guess I took us the long route to find that. That's also available here, where you can find both the private and the public IP address. So from that command line, from that PowerShell pane, we're going to type in that IP address of 10.20.20.4, and we're going to use some parameters here, like specify the port that will be utilized for an RDP remote desktop connection, and that's going to be port 3389. Let's press enter. And here we will get some feedback. We see that the VM is attempting a TCP connection from this device to the remote virtual machine that lives within the manufacturing VNet. And here we notice that the VM that lives within the manufacturing VNet is initiating a TCP connection and a ping ICMP test from this virtual machine to the virtual machine that lives within the test VNet on the core services, test VM on the core services VNet. So here we can see the feedback, the results from that testing. We see warning that the TCP connection to our virtual machine at 10.20.24 port 3389 has failed. We also see that the ICMP ping test to 10.20.20.4 also failed with a status of timeout. So we can use this feedback to understand that this was a failed test. There was no communication that was traversed between the two virtual machines through their respective virtual networks. So therefore, we're able to conclude or confirm from this test that because our virtual machines live within different virtual networks, that communication is still not able to traverse the two different VNets. These are still isolated virtual networks that do not allow network traffic traversal between different virtual networks. However, that's what we are going to resolve with our task number 4, where we will create virtual network peering between the core services VNet and the manufacturing VNet. And then we'll come back and test this net connection again once we've bridged that communication. So from our virtual networks page on the Azure homepage, back here to virtual networks, we're going to go to the core services VNet. And under the core services VNet, we're going to go to settings, and we're going to select under the settings menu, we're going to select peerings. And let's give this a moment to load. Now, once we arrive at the peerings blade, we're going to click on add. And the goal here is for us to add that peering connection between this VNet, which is the core services VNet, and our remote VNet, which is the manufacturing VNet. So we will fill out the relevant fields here to establish that peering connection between these two different virtual networks. We're going to give our peering link a name. We'll go ahead and name it Core Services VNet to Manufacturing VNet, which is a very great description of what its actual intended to do. Traffic to remote virtual network, we want to allow that traffic to traverse to the remote virtual networks, and that is actually allowed by default. It's not something that we need to change here. Traffic forwarded from remote virtual network, we want to allow that traffic as well. And for the virtual network gateway or route server, we want to select none, default. We don't have any virtual network that is involved in this scenario. And then finally, for the remote virtual network, we need to establish that peering from the remote end as well. So what this is saying that we actually have to create the connection from both ends of the peering connection. One from the core services VNet side and one from the manufacturing VNet side. So now it is time for us to deal with the settings on the remote virtual network, which is our manufacturing VNet. And we're going to name this peering link manufacturing VNet to core services VNet. We're using the resource manager deployment. We're not going to paste in a resource ID because we're going to actually select the virtual network here from the drop-down list. Select the appropriate subscription from the drop-down box. Our virtual network that we are peering with is the manufacturing VNet. That's our remote virtual network. And then we have the final settings here to allow traffic to the remote virtual network. We want to allow traffic forwarded from the remote virtual network. There is no virtual network gateway or route server involved in this scenario. And then we can click on the add button. This will kick off the creation of our virtual network peering connection between the two virtual networks. I will go ahead and press pause on the video, and I will resume once that connection has completed creating. And it appears that the peering connection has successfully completed the creation process. Note that in the peerings menu, Core Services VNet to Manufacturing VNet, our peering status shows the state of connected. That's a good sign. And the peer network from Core Services VNet to the peered network is the manufacturing VNet. So this is a really good positive sign. This is exactly what we're wanting to see here. Now, if we were to examine the same from the opposite end of the connection at the manufacturing VNet side, we see that we have a reverse connection of manufacturing VNet to core services VNet, which we created during the peering connection creation process. We also show a status of connected from this end as well, and that the remote connection, the peer connection, is the core services VNet. So we have the manufacturing VNet to the core services VNet side of the connection is successfully connected as well. And these are important items that you want to check in the event that you are having any types of communication issues between peered networks to ensure that your status is in a connected state. So our final task here is to test the connection between the VMs again, now that we have established that peering connection between the two virtual networks, between the two VMs that live within the two different virtual networks. So we're going to go back to our test VM connect here. We're going to go back to our manufacturing VM. And on our manufacturing VM, we want to repeat the command. I'll go ahead and click on, I should be able to click on up. There we go. To repeat that command, and I'll press enter. And here we see that this virtual machine is attempting a TCP connection to the remote VM and also an ICMP connection to the remote virtual machine. And notice the difference in the results that we see here. We have the remote PC's IP address. We're not using DNS, so we do not see any domain name or FQDN fully qualified domain name here. We have the remote address as well. The remote port is the RDP port, which is 3389 default port. The alias interface here using the Ethernet port. This is sourced from the IP address of the manufacturing VM, which is the 1030.10.4, and we see that our test succession here has been a status of true. So we have successfully been able to achieve network connectivity between the virtual machine within our core services virtual network to the manufacturing VM that lives within our manufacturing VNet. And this was the objective that we intended to achieve here, was to establish that communication or that connectivity between two isolated virtual networks to allow network traffic to traverse between them using a mechanism known as virtual network peerings. So that's all I have for this video. We've successfully achieved the objectives here, and we have successfully configured that connectivity between the VNets by adding peering connection. Thank you for watching, and don't forget to click on like and subscribe so that you can be notified about my future videos.